Hi all, today I am going to discuss you with the most interesting topic in AI, CycleGAN. So before going to the topic, let's briefly explain what is GAN. GAN means Generative Adversarial Network. It's a powerful class of neural network and used for unsupervised learning. Unsupervised ലേണിംഗിൽ യൂസ് ചെയ്യുന്ന ഒരു പവർഫുൾ ക്ലാസ് ഓഫ് ന്യൂറൽ നെറ്റ്വർക്ക്സ് ആണ് GAN. And it was developed Goodfellow in 2014. GANs are basically made up of a system of two competing neural network model which compete with each other. GAN divided into three parts. First one generative, adversarial, and the last one is network. Generative means to learn a generative model and it describes how data is generated, and adversarial means the training of generated model take place in a adversarial setting, and the last one is network. We use deep neural network AI algorithm for training purpose. In GAN, there is a generator and discriminator model. The generator model generates fake sample of data and tries to fool the discriminator, while discriminator tries to distinguish between the real and fake sample. And these steps are repeated several times. So this is all about GAN. Now let's start our topic, CycleGAN. We know training a model for image-to-image translation requires large dataset for paired example, and this dataset sometimes difficult to prepare and expensive in the case of photograph of painting by long dead artist. So CycleGAN is introduced for automatic training of image-to-image translation model without paired example. The models are trained in an unsupervised manner using set of images from source domain and set of images from target domain that do not need to be related in any way. Okay, unpaired set of imagesനെ ഇമേജ് ടു ഇമേജ് ട്രാൻസ്ലേഷൻ നടത്താൻ വേണ്ടിയിട്ട് 2017 കൊണ്ടുവന്ന ആർക്കിടെക്ചറാണ് സൈക്കിൾ GAN. ഒരു തരത്തിലുള്ള ഇമേജസിനെ മറ്റൊരു തരത്തിലേക്ക് പെയർ ഓഫ് ഇമേജസ് ഇല്ലാതെ ട്രാൻസ്ലേറ്റ് ചെയ്യുന്നതിനാണ് സൈക്കിൾ GAN എന്ന് പറയുന്നത്. സാധാരണ GAN ഉപയോഗിച്ചിട്ട് ഇമേജ് ട്രാൻസ്ലേഷൻ നടത്തുകയാണെങ്കിൽ നമുക്ക് പെയർ ഓഫ് ഇമേജസിൻ്റെ ഡാറ്റാസെറ്റ് വേണം. ഇപ്പോൾ ഒരു എക്സാമ്പിൾ പറയുകയാണെന്നുണ്ടെങ്കിൽ ഒരു ഓറഞ്ച് എന്നുള്ളതിനെ നമ്മൾ ആപ്പിളായിട്ട് ട്രാൻസ്ലേറ്റ് ചെയ്യണമെന്നുണ്ടെങ്കിൽ അതിന് മാനുവലായിട്ട് ഓരോ ഫോട്ടോ നമ്മൾ ക്യാപ്ചർ ചെയ്തിട്ട് വേണം ട്രെയിനിങ് ഡാറ്റാസെറ്റ് ഉണ്ടാക്കാൻ. ബട്ട് ഇൻ ദ കേസ് ഓഫ് സൈക്കിൾ GAN, the automatic training of image-to-image translation occurs. CycleGAN is a simple and powerful technique for achieving visually impressive results on a large range of application domain, most notably translating the photograph of horse to zebra and reverse. When we translating photograph of horse to zebra using GAN, we can require dataset of paired images. It's very difficult to find overlapping image of horse to zebra. Here is the need of CycleGAN. We can train AI using CycleGAN. These are the examples of image-to-image translation. Using CycleGAN, we can translate summer landscape to winter, and translating the painting to photograph, and translating the horse to zebra. CycleGAN is a successful approach for training unpaired image-to-image translation using GAN model architecture, and CycleGAN is an extension of GAN architecture. It involves the simultaneous training of two generator model and two discriminator model, and these two generators are often variation of autoencoders. They accept one image as input and output another returning image. So an autoencoder means it's an unsupervised learning technique for neural network that learn efficient data representation by training the network to ignore signal noise. An autoencoder network has three layers: the input layer, hidden layer for encoding, and the output layer for decoding. So the working of autoencoder, The autoencoder network teach themselves how to compress the data from input layer into a shorter code and then uncompress that code into whatever format best match the original input. So this process sometimes involve multiple autoencoders. When we take the diagram of CycleGAN, we can see this two generator and two discriminator. So the working of generator and discriminator are different. The generator take image from first domain as input and output image for the second domain. So the first generator take an input image from first domain and the other generator take image from the second domain as input and generate image for the first domain. And the discriminator model are used to determine how plausible the generated image and update the generator model accordingly. So discriminator used to determine the plausibility of generated image and it update the generator model. CycleGAN has two objectives to do with its main generator, that is the first generator. It makes sure the translated image look like same. That is, when we take the example of translating image of horse to zebra, it check that the image is similar to the zebra, and it train the generator using GAN. Here the generator and discriminator train against each other, and here the discriminator look whether the zebra is real or fake that made by the generator, and generator work just as the discriminator works. So the generator always tries to create image and make the discriminator believe that it is real. So we have to create an image that make the generator believe that it is a zebra. The problem is that when we using this, the generator will do anything to the original image in order to convince the discriminator. So that is where the second objective comes in. It makes sure that the translated image bears a resemblance to the original image. We do this using a term known as cycle consistency laws and the second generator. The second generator will also work on these laws. The first generator will modify and translate it and as needed. The second generator will try to make the translated image look like the original image. So, as the name suggests, it worked like a cycle. At first, the first generator will accept the image from first domain as input, and the second domain image from the it will be given to the second generator. It will try to make it look like original image. So, if so, it will stop there. If not, the cycle will be repeated. So this is the working and objective of CycleGAN. So now let me go through the term known as cycle consistency laws. It is very important in CycleGAN. The cycle consistency laws mean when we translating an image, that is the original image to translated image, the original image have some laws. So these two generator will try to minimize the loss, and this loss is called cycle consistency loss. Cycle consistency is the idea that an image output by the first generator could be used as input to the second generator and the output of the second generator should match the original image. It means the output of the second generator match the input of the first generator. The reverse is also true. Cycle consistency is a concept from machine translation where a phrase translated from English to French should translate from French back to English and be identical to the original phrase. It means there is no loss between these two translations. Instead of developing a CycleGAN architecture, we will develop an architecture for two GANs. We know each GAN has a discriminator and generator model, meaning there are four models in total. So the first GAN will generate photos of winter when we given the photos of summer, and the second GAN will generate photos of summer given the photos of winter. That is GAN 1. It translates photos of summer, that is collection 1, to winter, that is collection 2, and GAN 2 Translate photos of winter, that is collection 2, to summer, that is the collection 1. So the architecture of CycleGAN is very complex, but when we take an example, it becomes more easy. So we have a problem. We are interested in translating image from summer to winter and back winter to summer. So we have two collection of images. Collection 1 have photos of summer landscape and collection 2 photos of winter landscape. And these two collection of photograph and they are unpaired. Unpaired mean they are photos of different location at different times. We don't have exact same scene in winter and summer. And each GAN has a conditional generator model that will synthesize an image given an input image. And each GAN has discriminator model to determine whether the generator to determine the plausibility of generated image. We can summarize the generator and discriminator model from GAN 1. Generator model 1 input take the photos of summer from collection 1 and output generate photos of winter. And discriminator model take the photos of winter from collection 2 and output from generator model 1. It means it check whether the photos of winter made by the generator is real or fake. And similarly, we can summarize generator and discriminator model from GAN 2. Generator model 2 input take the photos of winter from collection 2 and output generate photos of summer. And discriminator model 2 input take photos of summer from collection 1 and output from generator model 2. It check whether the photos made by the generator model 2 is real or fake. So the models are sufficient for generating plausible image in the target domain but are not translation of the input image because the generator will do anything to the original image in order to convince the discriminator model. Cycle consistency laws compares an input photo to the CycleGAN to the generated photo and calculate the difference between the two. Example using L1 norm or summed absolute difference in pixel value. So the last topic is application of CycleGAN. CycleGAN is used in different fields like style transfer or object transfiguration, etc. So let us go through it. CycleGAN is used for style transfer, translating paintings to photograph, and it is used in object transfiguration for translating images of horse to zebra, zebra to horse, and apple to orange, and orange to apple. It is used in season transfer, translating winter to summer and summer to winter. And CycleGAN is used for photograph generation from paintings and photograph enhancement for improving the depth of field on photos of flowers. So this all about CycleGAN. Hope you understand and thank you all.